Hello, my name is Jet Scanlon, and this is my OOP assignment demo. We're going to start things off with Assignment 1. Assignment 1 is all about setting up the Java files. The first thing in Requirement 1 is adding the external library. If we go over to Eclipse, we can see the external library is under there. To add an external library, we right-click on TeleGraphics and go to Build Path, add external archive. We can also do this through Configure Build Path. Go to Library and under Class Path. The next thing in Requirement 1 is about the main class Java file. As you can see, we have the main class Java file up here with some stuff in. Not everything is in here, as we'll go in later on, but everything has been moved into the graphic system.java file. The next thing about, so that's that one. The next thing about it is the about method. If we go back to Eclipse, in this, we can see there's an about method here. If we undo that and run it, we should see that the default tail starts moving and doing the OOP symbol. That shows that. After that, we go to this bit where we have to create the graphic system.java file and connect it to main class while using this file, the graphic system.java file, to add all the commands in. As we can see, we connected it through that, and this is the file which extends the lead LBU graphics and with all the code in. The next thing after that for the Requirement 1 is the about method, which is about running the code and seeing if you can use this about method here as a command prompt instead. So as we can see, we can run the jar file and type about in, and he will do the same thing as what would have happened if we uncommented the about. The next thing after this is Requirement 2. Requirement 2 is about inputting all the basic commands for people to use. The first command is pen down. We will see this by running this software again. So when we get down here, we can see pen down is here. This is the bit of code that allows a user to input pen down, and it will show the message and do what is needed. So if we do pen down with no spaces, pen is down. We can test this by going forward 100. As we can see, there is a clear mark of where the pen has been. There are a bunch of other commands that we also have to do in Requirement 2, like the forward one, which we would know as just going forward. But this won't work at the moment, because if we go to this and run forward, it's going to come up with invalid command up here. That is because we need a parameter, which is here. So the user gets to input how much forward it actually goes. If we go back to this and run it again, if we type in forward 100, we'll have a command and a parameter. Once we run that, it'll go 100. The reason why there's no line is because pen is currently up, since we just restarted the software. We can see the forward command up here with the parameter and all the code with it. How we managed to make it so the input of the user is a parameter is by splitting the user input into substrings. The first part of the substring, which is here, is given the name command name because it's the simple command name that won't change and is a part of all these. The second part is then used as a integer to make sure it's not string, which we'll go back into in a second because it will need an error for it. But it will come back as a integer, and the code will know that's how much further to move. The next part after that is backwards, which only works when with this code here, which we do negative forward instead, because there is no default backwards command. As we can see, if we go run this again and type backwards 100, the turtle will move backwards. That also shows the next part, which is about the perimeter again, which we showed off earlier. Since it's using the exact same strings and setup, all we have to do is add backwards into this case log here. The next thing after that is turn left, and turn left with a perimeter. We can see that turn left is in case here, so it should work with a perimeter that a user inputs. So if we run the code and type turn left 90, it will turn left 90 degrees for the turtle. It turned right for us. It's because it's the way the turtle is facing. So the turtle turned left. Now to see that it actually will make a line, we're going to do pen down. And then forward 100. As we could see, it clearly has drawn a line going the direction of the new direction of the turtle, proving that the turn left command works. The same can be said for turn right, since it's the exact same except just the opposite. As we can see here in this bit of code, we have turn right and it's perimeter again. So if we go to this and type in turn right 90 degrees, it will go back to facing downwards because it has turned right 90 degrees for where the turtle is facing. If we then do forward 100, it then carries on moving, drawing a line. As we can see, we've got a 90-degree angle there, proving that the turning works. The next thing after this is pen up. Because we have to manually put pen down for it to start drawing, we can also put pen up, which would also mean that the pen is up, so it won't draw a line. So if we turn right 90 again, and then forward 100, we would expect it to not draw a line, as we can see. Pen up is in a different section on my code compared to these set of commands, because these have parameters and these don't, so they don't need that complex method. All you have to do is just label what the input is going to have to be and what command it goes to, with a basic display message just to show that it worked. As we can see, pen up is here and pen down is here. So we can see that they do the opposite of each other while working. The next thing after this is black, which is used to turn the colour of the line a different colour. As we can see, there are 4 different colours: black, green, red and white. If we go into the command, we can see the colours are listed here, the same as other commands earlier like pen down and pen up. They just change the colour of the pen. If we go here and do green and forward 100, we need to do pen down. Let's clear and reset. Right. So pen down and forward 100. We can see it's made a green line. If we then turn right 90 degrees, we can then change the colour again to white, which is another colour we have operated this. If we then go forward 100 again, you see a white line. If we turn right again by 90 degrees, we can change the colour to red, which is another colour. Same there. If we then go forward 100, there's a red line. So if we turn right again at 90 degrees, we will finish off the square, but we kind of won't, because you won't be able to see the next colour because the next colour is black. Now, while it is black, we won't actually be able to see if there's any colours put down because the background is black. That is it for requirement 1. No, there's a bit more. There is clear and reset, which are also here. Same as the other commands we've done, where it doesn't have a parameter for the user to input. Clear will get rid of any drawings in the box, so you can start again. Reset will put the turtle back at its original starting position. Requirement 3 is all about validation, and the first part of this validation is to see what would happen if you inputted the wrong command. So if we go back to Eclipse and then type in a different command, like XXX, it's not a listed command that we've listed, so it comes up with an invalid command up here. The next part is making sure that there needs to be a parameter for any movement-based commands. So when it does happen, the user can control which direction and how much it can move. So if we go back to Eclipse, we can see if we do just forward and leave it blank, nothing will happen because it's an invalid command. If we then go back, we can see it talks about the parameter being non-numeric, which of course wouldn't happen because it needs to be numeric to then see how far forward it can go. And so if we go back into Eclipse and run it, we can see if you then went forward XXX, it would come up with invalid parameter because it needs to tell the user that they've inputted something wrong. So I've made it 2 different errors to tell you which part of the string is wrong. So if we put forward 100, which is an integer, it will go forward 100. The next part which I have done is requirement 5, where it talks about the about method and overwriting it so that when the dance happens, in the corner where the other messages have been showing, it will show my name instead. So if we go back to Eclipse, and you can see the about method, all it took was a little display message just with my name in it. So if we go back to this and type in about, it will do the command as prompted. which is the default OOP. As you will see where this is in a second, it will change to my name. Now there is a thing I forgot to explain about the more complicated method about one of the requirements in requirement 3 is this one about having these parameters and all that. It was a bit of annoying, but we managed to get the third part about having the non-numeric parameter and coming with an error. How we did this was, since we already split the substring to create a parameter, we compared the second substring, which would be the integer, which is this one, this line. It would compare it to see if it's an integer. If it is an integer, it'll carry on through it. Since it's a try and catch, it will just try and go through all of it and see if it's a number at the end. If it doesn't come back with a number, it will then display this message which we saw earlier, displaying invalid parameter. That is my code and demo for OOP. As we can see, I didn't do any much else, as we will submit the form now. And I hope you enjoyed watching this, and I know I fumbled over my words a bit, and did that bit of requirement 3 at the end by accident because I skipped over it, not really going through the code as much. But I hope this was good enough. So thank you, and bye.